All right, hey guys, we are going to try a new format for our video lessons and notes. So I have a new electronic piece of equipment to give a shot. We'll see if we like this more than the previous chapter notes. All right, so let me present my screen and we'll get started. Okay. So for chapter 2, we're going to start with some vocabulary. We just have 4 terms to start with. First is quadratic function. All right, you guys studied these in Algebra 1, but we're going to study them in detail in this chapter. A non-linear function that can be written in the standard form, y equals ax squared plus bx plus c. So we're going to look at some in standard form, but then we're also going to look at vertex form. That's what we're going to focus on today. F of x, equals a times the quantity x minus h squared plus k. All right, just like we have different forms of a linear equation, we have slope-intercept form, we have point-slope form, we have standard form, and each form gives us different bits of information that we can quickly retrieve, right? So vertex form of a quadratic function allows us to identify the vertex very easily and also talk about the shifting of the graph, okay? A parabola, the next term here, parabola, that's just the name we give to the U-shaped graph when we graph a quadratic function. Okay. The next term, the vertex of a parabola. Okay, the lowest point on a parabola opens up, or the highest point if it opens down. So here we have a parabola that opens up. So this is the vertex of the parabola, the very bottom of the parabola. If our U was flipped and opening down, then the very tippy top would be your vertex. Finally, as I said, we're going to be studying vertex form in this lesson. It says vertex form of a quadratic function written in the form f of x equals a times the quantity x minus h squared plus k, and a cannot equal 0. All right, so the important things to note here, and I'm going to write on the bottom of the paper, right? When you're in vertex form, so again, that is, let me see here. Okay, so when we are in vertex form, that's f of x equals a times the quantity x, minus h squared. That's an x, guys. X, try to make it better, minus h squared plus k. Okay. Now, the a value right here is going to tell us if our graph opens up or down, if it reflects over the x-axis. So, reflection in x-axis. All right. It's also going to tell us if we have a vertical stretch or shrink. So vertical stretch, think of you stretch vertically, you kind of get taller and leaner. A vertical stretch is going to be a skinnier graph. A vertical shrink, think about your parabola, your U-shape shrinking away, moving away from the vertical axis. Your parabola is going to get wider. All right, the H value right here is going to tell us if our graph had a horizontal shift, okay, right or left. So I'm just going to write right or left. Okay, the H value is going to tell us if we moved right or left. And then finally, the K value is going to tell us if we moved up or down. We call that a a vertical translation, right? Vertically moving up and down. So that's a vertical translation. Okay. All right. So go back to my mouse. Actually, I think I can stay in my pen. Just come over here. Nope. Sorry, guys. I'm still trying to figure this out. So I have to click on my mouse in order to move down. There we go. Bear with me. All right. So get rid of that. All right. So this next page just gives us a lot of details that won't fully make sense to you guys yet, but as we go through the problems, it will. Okay, so we're going to be talking about a translation, a horizontal translation, right or left. Remember, I told you the H value. So here it says when H is less than 0, we're moving left. When H is greater than 0, we're moving right. Okay, a vertical translation, that's the K value we're going to be looking for. So when K is less than 0, we're moving down. When K is greater than 0, we're moving up. All right. Next, we have reflections in the x-axis. Okay, so when the, where is it? Sorry. When you have a negative out front of that x squared, you're going to say that it reflected over the x-axis because all the y values are changing sign. Over here, if the negative is inside the parentheses, so it's changing the sign of the x, that means it's reflecting over the y-axis. All right, and then finally, we have horizontal shrinks and stretches. So if there is a number inside the parentheses with the x, okay, multiplying the x values, that's going to be a horizontal stretch or shrink, depending on what the a value is, and we'll talk about that. And then if the a value is outside of the parentheses, it's a vertical stretch or shrink. Okay, so we're going to get right into graphing. It says describe the transformation of f of x equals x squared represented by by the new function, and then graph the function. All right, so we're going to write a little bit on the bottom of this page here. Okay, so my parent function is f of x equals x squared. I'm going to write that down. And then my new function is g of x equals x squared plus 4. Okay, so I'm going to remember all that. Maybe I can write it next to the graph, actually. All right, so let me come over here and get my pen. Okay. So the first function we have is is it not one to move? There we go. Sorry, guys. Okay, the first function we have is the parent function, which is f of x equals x squared. Now, for your parent function, this is why I had you memorize the key points and how to graph the parent function. You need to know that the parent function graphs at 0, 0, 1, 1, point, negative 1, 1, and then 2 go up to 4, and then negative 2 up to 4. And obviously the points are a little bit off. If I wanted to continue, I'd go out to 3, and then 3 squared goes up to 9. Okay, but that was not one of the key points that I had you memorize, but still a good point to know. And then if I go out to 3, 3 squared is positive 9. Okay, so that is your parent function. Try to draw my parabola. Yeah, okay, you get the idea. All right, so our new function that is given is g of x equals x squared plus 4. Okay, well, if you think about the vertex form, it's a 2, sorry. If you think about the vertex form, remember vertex form is a and then x minus h squared plus k. Knowing that that 4 is your k value is super important. It's not the h value, because the h value would be in parentheses with the x value being subtracted or added. All right, so that is your k value. That means the 4 is telling you that you moved up 4 units. So moved up 4 units. So if you moved up 4 units, all you're going to do to graph your new function is plot each of these points up 4 units. So 1, 2, 3, 4, right there. All right, and then this point would move up 4, 1, 2, 3, 4. This point moves up 4, 1, 2, 3, 4. Right. This point moves up 4. It's supposed to be right here. 1, 2, 3, 4. this point. 1, 2, 3, 4. Okay. Notice that for your f of x function, your vertex is located at the origin. Okay, so your vertex for the f of x, vertex, is located at the origin, 0, 0. For your g of x function, where is the vertex located? And what is its coordinate? Its coordinate is 0, 4. So something to keep in mind is that your vertex can be discovered by looking at the graph, or looking at the equation, and just looking for the h and k values. The h value for this equation is 0. There is no h value written, so it's a 0. The k value is 4. So 0, 4 is the vertex. Up in the parent function, there are no h and k values written. That means they're both 0, so your vertex is 0, 0. Okay. All right, let's see if we can do another one. Maybe I'll be a little neater this time. So first I'm going to delete. Go back to my mouse. All right. Okay, so we're going to start again with the parent function. So the parent function is always the same. The parent function is f of x equals x squared. Okay, keep in mind that the vertex for the parent function is 0, 0. Parent function's key points are always going to be the same. So it's 0, 0. Then it's out 1, up 1, because 1 squared is 1. Then it's out 1, up 1, because negative 1 squared is 1. Then it's out 2, up 4, because 2 squared is 4. And then to the left 2, up 4, because negative 2 squared is 4. And again, if you want to continue, you could go up, out 3, up 9. Then it'll be out 4, up 16. Out 5, up 25. Out 6, up 36. I think you get the pattern. And I'll draw my parabola. So this is my parent function. All right, then I'm going to do my new function. So my new function is g of x equals x minus 1 squared minus 3. Okay, now I'm going to write vertex form underneath because I want to start looking at vertex form and comparing and talking about the a, h, k values. Okay, so let's talk about a, h, and k. So for the new function, all right, the a value is just a 1. There's no number written out front. That means it's automatically a 1. So a is equal to 1. All right, the h value, think about what number they plugged in for h here. They plugged in a 1. Keep in mind, it's already minus, so they just stuck in a 1 there. And the k value is a negative 3. All right, so from that information, since my a value is just a 1, there's no vertical stretch or shrink, it didn't flip up or down. H value being a 1 means it moved right 1 unit. And my k value being a negative 3 means that it moved down 3 units. Okay, so I'm going to go to my parent function. I'm going to move every single point, right 1, and then down 3. So right 1, down 3. There's my new vertex, which we'll talk about in a second. This point goes right 1, down 3. This point goes right 1, down 3. This point goes right 1, down 3. And this point goes right 1, down 3. Okay, and then you draw your parabola. Okay, notice the vertex for this function, h comma k, right? H comma k is your vertex. The vertex is located at 1, negative 3. And we can look at the graph now and see if that makes sense. It's located at 1, negative 3. Okay, let's try another one. All right, so start with the parent function again. So the parent function again never changes. It's f of x equals x squared, and its vertex is located at 0, 0. And the core points never change. So I have 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Again, I could keep going, but we'll just do those. Oh, that one's off a little bit. All right. Then we have our new function, which is g of x equals negative parentheses x plus 9 squared. So again, underneath of that, I'm going to write a times the quantity x minus h squared plus k. We're going to talk about the a, the h, and the k values. All right. This time, my a is negative 1. My h, what number was plugged in for h? Be careful here. How did it go from minus h to plus 9? I would have had to plug in a negative 9 because a minus a negative turns into a positive. So a negative 9 was plugged in. And there is no k value, so that means it's a 0. So your vertex, I'm going to kind of do something a little different here. Your vertex hk is negative 9, 0. Right? Now, your h value tells us that we moved left 9 units, okay? The k value means we didn't move right we didn't move up or down. And then the negative 1, if you remember from the beginning of the notes up top, I said that the negative out front means it's going to reflect over the x-axis because all the y values are changing signs. So we're going to reflect over x, right? If there's a negative up out front, that means your parabola opens down, okay? So let's plot the point. So to plot this one, I'm actually going to plot the vertex at negative 9, 0. Oh, I need to scroll down. Sorry, guys. Scroll down. Oh, no, that moves with us. I pretend that that didn't move. I didn't realize that was going to move as well. Yeah, let's just pretend that's not there. All right, so we're going to plot a point at negative 9, 0, which is, oh, gotta go back to my pen now. There we go. Oh, I'm going the wrong way. Oh my goodness gracious. Sorry, guys, let me fix this. I was thinking it was shifting down. It's not. It's shifting left. I'm not paying attention to what I'm doing. Maybe you're all yelling at me from your computer screens, or maybe you're not. I don't know. All right, trying to get this back where it was. There we go. Sorry, guys. So the vertex is negative 9, 0, which means that I have to go left 9, not down 9. So let's do that. I'm going to go left 9 units. And then I know it reflected. It means it flipped upside down. All right, so all my points are going to go down this way. And since there is no horizontal stretch or shrink, that means the pattern stayed the same. What I mean by the pattern, I'm going to refer to the pattern quite often. If you think about the parent function, I'm trying to find my cursor here. All right, the parent function, there it is. The parent function goes from the vertex out 1, up 1, out 2, up 4, out 3, up 9, right? So I'm going to use that same pattern. From the vertex, I'm going to go out 1, down 1. And the same thing on the other side, out 1, down 1. Then I'm going to go out 2, down 4. Then I'm going to go from the vertex out 2, down 4. Okay, and I could keep going, out 3, down 9, and so on and so forth. But that, my friends, is your parabola. Okay, let's try another one. All right, so again, we're going to start with that parent function, which is f of x equals x squared, and it has a vertex at 0, 0. And the parent function core points are always the same. The pattern never changes. 0, 0, out 1, up 1, out 1, up 1, out 2, up 4, out 2, up 4, out 3, up 9, and so on and so forth. Okay, there's your parabola. Your new function, this g of x function that was given, so g of x equals 1/3 x squared minus 6. Okay, and I'm going to write a times the quantity x minus h squared plus k. And we're going to list our a, h, and k values. We're going to talk about what it does to the graph, what the vertex is, and then we'll graph it. So the a value here is 1/3. The h value here, okay, is there a number inside the parentheses with the x? Nope, so the h value is 0. And the k value, that's that tail end, that's -6, okay? So the -6 means I'm going to move down 6 units. And the 1/3 means that there's a vertical shrink by 1/3. Okay, and I'm going to explain that, how we graph it in just a second. Vertical shrink. So when I graph this, I want you to, again, visualize. When you stretch up vertically, what happens to your body? You get taller, you get leaner, right? If you shrink away from the y-axis, the parabola should get wider. Okay, so keep that in mind. So the vertex is at 0, -6. We're shifting down 6 units. So this time I do have to move down. And that parabola, unfortunately, is going to move with me. That's okay. Let's see. Maybe I need to erase. Is this my eraser? Yeah, I think I should erase this to start. There we go. Back to that. Scroll down. All right. So my parabola is going to move down 6 units. So I'm going to plot a point at 0, -6, because that's where my vertex is. Now, the vertical shrink of 1/3 means that when I do my pattern of out 1, up 1, out 2, up 4, out 3, up 9, my up movements, I'm only going to go up 1/3 of the way because I'm shrinking vertically by 1/3. So I'm going to go out 1, and instead of going up a whole unit, I'm going to go up 1/3 of the unit. So about here, right, 1/3 of the way. Of course, my points aren't going to be exactly located where they should because this isn't very precise, this little tablet that I'm using, but it's out 1 and then up 1/3. Now I would go out 2, and normally I would go up 4, but I only want to go, oh, that's not 4, 1, 2, 3, 4, but I only want to go up 1/3 of that way. So if you need to do the math over to the side, you can. 1/3 times 4 is equal to 4/3, or another way of writing that is 1 1/3. Okay, so what that means is I'm going to go out 2 and then only up 1 1/3. Out 2 and up 1 1/3. Okay, now I am going to keep going with the pattern because the next one works out nicely. If I go out 3, I normally would go up 9 because 3 squared is 9. But I only want to go up 1/3 of 9. 1/3 of 9 is 3. So it's going to be out 3, up 3. Out 3, 1, 2, 3, up 3. I can't count, guys. 1, 2, 3. It's right under this thingy here. Oh, maybe I can move it. There we go, right here. All right, and then I draw my parabola. So notice how my oddly shaped parabola got wider. It shrank away from the y-axis, okay? All right, let's keep on moving. Okay, I think this is the last graphing problem we're doing. So I'll get started by writing the function again, the parent function. So the parent function is f of x equals x squared. And the vertex is at 0, 0. So I'll plot that point here. The core points are out 1, up 1, out 1, up 1, out 2, up 4, out 2, up 4. Okay, there's my parent function. Now the new function is g of x equals negative 4x squared. Okay, so a x minus h squared plus k. All right, so for this example, a, h, and k. The a value is negative 4. The h value is 0. And the k value is 0. Okay, so that means your vertex stays the same. Your vertex is at 0, 0. All right, but the a value, and careful, this is different than the last one. The a value, because it's inside the parentheses with the x, that means that it's going to reflect over the y-axis. Let me get rid of the vertex for a second. Let's try that again. So it means that it's going to reflect over y-axis. And then also there's going to be a horizontal. You think about the x values, a horizontal shrink by 1/4. Okay, so that means I'm going to plot at 0, 0 because I said my vertex stays the same. But if I'm shrinking horizontally, my out movements, remember the pattern, out 1, up 1, out 2, up 4, out 3, up 9. Your out movements, you're only going to go out 1/4 of the way. So instead of going out 1 unit, you're only going to go out 1/4 of a unit, but still go up 1. All right, out 1/4 of the unit, up 1. So your up movements stay the same. That part of the pattern doesn't change. All right, then I normally go out 2, but I'm only going to go out 1/4 of the way. Right, so 1/4 times 2, 2/4, 2/4 is 1/2. So I'm going to go out half of the way and then up my normal 4. That's not quite where I wanted it, but out half of the unit and then up 4. Okay, and that would be your parabola. So it's a very skinny parabola. Okay. All right, and the last two problems, which are not graphing problems, so we should be able to go through them a little faster. Okay, it says, consider the function f of x. Just get my pencil and then I'll finish reading. Okay, consider the function f of x equals negative 10 times the quantity x minus 5 squared plus 7. Describe the transformation of the graph of the parent function. Identify the vertex. This is what we've been doing, but we just don't actually have to graph. All right, so I'm going to write f of x equals negative 10 x minus 5 squared plus 7. And under that, I'm going to write a x minus h squared plus k You're going to list your A, H, and K values and tell me what each of them is doing to the graph. So A is -10, H is 5, and K, oh, I wrote K up here instead of 7. That should be a 7, guys. K is 7. Okay, so the -10 means it's going to reflect over x-axis and have a vertical stretch by 10, by a factor of 10, okay? Your 5 inside the parentheses means that you're going to move right 5 units. And your 7 means you're going to move up 7 units. All right. And the last problem, trash, do my mouse, over here. Oh, too far. Okay, so the last problem says, let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis followed by a translation 3 units down. So we want to rewrite a function. We want to name it G of x, and we want to perform all those transformations stated. Okay, well, a vertical stretch of 2. All right, if you think about your A x minus h squared plus k, where does that 2 go? Vertical stretch of 2. It gets replaced with the A, or A gets replaced with the 2. Okay, a reflection in the x-axis. What tells us it's a reflection in the x-axis? That negative, that's what's going to flip it and make it open upside down. Followed by a translation 3 units down. Which of these variables tells us moving down or up? That's the K. All right, so I'm going to have -2 and then x squared minus 3. This is your K that's saying to go down 3 units. This is your A. This is saying a reflection in the x-axis and a vertical stretch of 2. All right. All right, guys, so that is it. I know it was a little bit of a longer lesson. I promise I'll probably, hopefully, get more proficient with using this tablet and it'll go faster next time, okay? That's it for today. Have a great day. Bye.